Project 1. In this project, what we're going to do in metallurgy is we're going to take a look at building what you see up there, which is basically a smartphone stand. It's made of sheet metal, and you're going to get to select what type of metal you want to make it of, but basically we're going to have a similar design to what you see there, and I'm going to step you through the very beginning stages. There's actually 3 videos in this series. This first step is going to basically be just how to model that part. Then the second step is to actually put in a design similar to what you see this little opening that we have here. You're going to be able to design an opening for it that would be essentially laser or plasma or water jet cut. And then from there, we're going to go ahead and do what's a simulation on it to test it as if it were being dropped from a 5-foot shelf. And we'll see what the results are with the material that you selected. And then you'll do a little bit of a research paper, only about a paragraph on the material that you select. And it has to be a metal. It could be iron or aluminum, copper, whatever you like to choose. And you're just going to have to write a little bit of information about it and then assemble this document and turn it in. So this is the first part. Now, the metallurgy information, if you go to Vertanu1, vertanu1.com/metallurgy.html. There you'll find everything you need pretty much for this. And so the metallurgy training guide, which I have up here, actually has the samples. What I'm going to have you do first is, as you can see here, I'm going to pass out some drawing paper, and you're going to hand sketch a little bit of a design here. Actually, we'll do that after we actually come up with our design for our phone. Here is a sample of just information you'd grab off of the internet. This was off of Wikipedia. I don't want you can use Wikipedia, but you have to change it. Otherwise, remember, you have to put it in quotes and source it properly. So that will come later. But here we can see the drop test analysis that we're going to go ahead and complete. And as we move further up here, there we go. There's actually the what we're looking to create, this profile. So let's begin with SolidWorks. First of all, start up SolidWorks 2016 on your screen. And you're going to go to up here, there's a little white sheet of paper, new. But otherwise, you could actually see over here, there's this little arrow right here. If you go to that little arrow, it gives you the pull-down menus. And I like using the pull-down menus. They're a little bit easier to navigate than just telling you, or just trying to describe an icon to click on. But once you get that, tack it in with that little thumbtack, and now go to File, New, and select Part. Just click on it and hit OK down here at the bottom. Now, what you'll see in this view screen is on the left, that's called the feature tree, or the Feature Manager Design Tree. It's going to contain all of the history of everything that you do making this part, everything from the sketches to the extrusions or features that are created. Up top is your ribbon, these little tabs. This is the ribbon tab. And so essentially you'll have features and sketch. Go ahead and click on sketch. All right, those are all your sketch tools up there. Lines, circles, arcs, rectangles. That's what you could use to sketch whatever type of geometry you want. Go ahead and select the front plane here on the feature tree. You'll see they all highlight the front plane. Actually, you'll see when you click on it, you see it highlight in blue. Actually, instead, because this is going to be a phone stand, let's select our right plane, and we'll draw the right side of the phone stand, versus if we were to draw it on the front, our phone stand would be sitting sideways. So let's click on the right plane, and right here, you might get this quick launch tool to appear. If so, it's right next to the eyeball. Click on that sketch, and it will start a sketch on the right plane. Otherwise, go up here to the Sketch tab and click on Sketch here. Beware, do not click on 3D Sketch or 3D Sketch on Plane. Even though this is a 3D modeler, we're not using that. So click on Sketch by itself. Okay, now take your line tool. And our goal is to create what was in the book there. And I'm on page 25 of the manual. And you can see it's an angle bracket design somewhat. So we're going to first actually go up here and hit the little arrow to the right of line and find center line. We're going to draw that center line first. So when you click on it, now you can move your pointer and you have a cursor, and it turns orange once you get it to that red origin. That's your center marker in space, your 0x, 0y, and 0z. When it turns orange, click and drag up a straight line, just like I have. One way you know it's straight, if you get the little yellow box to the right of the pointer and it has a vertical line in it, that means it's straight vertically. And make it about 3 inches. Now that number that you get there, it's just to get you close. Don't worry about it. We're going to add dimensions later on. But it's just to get you about 3 inches or so is pretty good. Click. And then you'll see it will try and chain. Hit your escape key in the upper left corner of your keyboard, and it will take you out of that chain. Okay, now again, we need to take a look at the manual here. And we have a line going at a 30-degree angle off of it, and then another line at 60 degrees, and it's aligned to the base, and then this little angle here. So, and it's 2.5 inches in length. So here's what you want to do. Now use just the ordinary line tool. It's just line, not center line. Line this time. And start off at that origin again. When it turns orange, click and drag it at an angle. And remember, it's about 2.5 inches, so look for about 2.5, and you have it at a slight angle like where mine is. So 2.73, that's fine, as long as it's close. Click. Now drag down and drag it down about at this angle, and see how I can infer across. I get that little dashed line. That's an inference line, means it's locking in vertically to that center. But it's actually not going to lock permanently, but it's just snapping to it. Go ahead and click, and now hit escape. Let's add some dimensions there. Go to Smart Dimension up here in the upper left. Click on it. Click on the actual center line. Now, a lot of people like to click on the ends or the middle of the center line. Stay away from those for right now. Click on the line as a whole. See how it all turns orange? I'm like right about here. Click. Now, same goes with this line. Don't click on the ends. Click somewhere on the line about where my pointer is so it turns orange. Click. And get in between those two lines where I am. And you'll see it gives you a dimension. Click one more time. When I say click, I'm saying click with your left mouse button, okay? And type in 30 on your keyboard. Now, you might have to hit the number locks if you're using the keypad on the right. Hit that little number locks button to make sure numbers are on. Otherwise, use the numbers at the top. That's fine too. And all you have to do is type it. Look, you don't have to click in here. It's automatically illuminated. Just type 30. You don't have to type 3.000, whatever. Just 30. Hit enter, and it will change that. Now let's do the same over here. Click on this line. Again, not at the ends, not in the middle, just somewhere on it so it turns orange. And now go over to this line. And don't panic when you see that weird dimension. It'll change in a second when we click on this line. Now get between the two, click and type in 60 for 60. It's a 60-degree angle. Go ahead and hit escape. Now what we want to do is lock this in vertically to that line. So hold control down. Now notice the control key is in the lower left corner. That's a typical one you want to use. Hold that control key down and don't let go. Now move your pointer over the origin. When it turns orange, click one time and release it. Now move your pointer to the right and click on that little dot while holding control. This one's the critical one. Control enables you to select more than one object. Otherwise it turns itself off. So click while you're holding control. And now over to the left, if you didn't get these little add relationships, hit escape a couple times and try that again. Holding control, select both points. 1, 2. Okay, on the left though, what we're looking for is vertical. Oops, and look at what that did. It moved it to the line. Now this is where we have the undo button up here. Take a look, there's undo. Hit undo up here. It's that little arrow. Now, let's go with horizontal and see what that does. Look at that. It aligned it. If we were to draw a line across here, it'd be perfectly linear to it. So there we go. Okay, now let's take a look. We want to go back to Smart Dimension and click on this line right here. See the one that's turning orange? And unfortunately, I still had something selected. So it's not a hard thing to just hit that little red X right here on Modify. I made a mistake. Now you could actually hit the delete key when something is selected. If it's not selected, hit escape and click on the line here, this thin line for the dimension, and hit delete on your keyboard. That's right above the arrow keys, the delete key. Go ahead and hit it one time and it deletes it. Okay, now what we can do is let's click on that line, just on it, not at the ends, and drag it out just a short distance. Notice it's parallel. This dimension is parallel. That's what you want. You don't want this. You do not want that. get it to where it's parallel, click, and type in 2.5. Again, you don't have to type 2.500, just 2.5, hit enter. And look at that. Now all we have to do is go back to the line tool now. Go up to line and glide up to this point right here, click, and follow this line out, maybe about an inch or so. Okay, right about there looks pretty good at an angle. And then follow this. Now look at this. I got perpendicularity. See that little perpendicular symbol? It looks like a half of an I-beam to the right of the pointer. It's in yellow. You want to try and get that if you can. Okay, and just click up here. Don't worry about the dimensions so much because we're going to add dimensions now. So it's just a little line at that angle and up here. But let's make this line perpendicular to this because I don't think I captured that. We could add a dimension of 90 degrees, and that's perpendicularity, but I'm going to show you an easier way. Rather than typing in numbers, hit escape on your keyboard about 3 times just to make sure you don't have anything selected. Now, holding control, select this blue line right here. And you're still holding control. Click on this line right here. And if you didn't get those two, hit escape a couple times, hold control, try selecting them again. Really, you only have to hold control for the second or third items. In this case, there's only 2, so it's just the second item. Over here to the left, you'll find perpendicularity. Click on that. Hit the green check. Now notice the line turns black. As you fully define these things, you know they're finished once they turn black typically. Okay, let's go to Smart Dimension. Click on this little line right here. You could click on the endpoints too. Either or is fine. But try and get it parallel like this. Get it parallel. Don't get it down like that's good, but don't get it down like this. You don't want that. So click here, and let me take a look at the manual. That needs to be 0.45. Now be aware, you could use a ruler on your, or a scale on your phone if you want to make this for yourself and change these so your phone fits. This was designed for like a typical smaller sized 4-inch screen, 4.5-inch screen, so this might not fit all. Now go ahead and click on this line. Again, stay away from the ends on this one. Drag this out again so it's parallel. It's a little tricky there, but once you get that down, let's take a look. The manual says that needs to be, you know, I don't have a dimension there, but let's go ahead and put one in. Let's make that 0.375. Okay. By the way, you might notice I'm actually in IPS here. This is how you change it from millimeters to inch pound second. Make sure it's an IPS. It might scale it, and you'll notice it's very small. If I forgot to tell you that earlier, my apologies. But you could go and double click on the dimensions and change them if you need to. The angle dimensions should stay the same. It would just be these. Okay, now I noticed, there we go. It looked like I had a little arrow there. Just want to zoom up. You could zoom up in and out with your scroll on your mouse. So that little wheel, just scroll it back and forth and point where you want to zoom up to and keep it focused, that focus point on it as you scroll back and forth, and you could rearrange it. Okay, we're ready to extrude this, but first we've got to bring up the sheet metal tab. Now, I have the sheet metal tab. You probably don't. You might, but if you don't have it, remember this is the ribbon. Right click on any of these tabs on the ribbon up here, and now we're right clicking, not left. Right click. That's the button we hardly ever use here. Right click and find sheet metal and check that box. Make sure it's checked. And then you should see the sheet metal tab appear. You might have to click on it. And now find base flange tab. The reason we're doing this in sheet metal is that we want to be able to flatten it and have it cut out using shears, or else we could use plasma or water jet or whatever. Okay, now for the width of this model, let's go ahead and again, I don't have it on here, so let's go with, first of all, in the upper left, look carefully what I'm selecting. Hit this little arrow to right of blind. Select mid-plane. Set it to 2.5. Oh, that's awfully big. So actually, let's go with 1.5. And you see it changes the width. That looks pretty good. Okay, now over here, there's sheet metal tools like sheet metal gauges. We're not going to use a gauge table, But the sheet metal parameters, as you can see here, this is the thickness. Let's go with a little bit thicker, like 0.062, 62 thousandths. Depending upon the sheet metal that you're using, if it's aluminum or if it's stainless steel, the thicknesses can vary for the gauges. So you have to be careful to look at your gauge tables. Usually you have them in a book. Each company is a little bit different how they have this, but we'll use 0.062. So it could be either, dependent upon, again, it could be a 16 gauge, it could be 12 gauge, depending upon what material you select. Don't worry about that right now, just make sure it's 0.062. And then here is the inside bend radius. 0.029 is a good bend radius. You could set it to 0, but sheet metal fabricators typically don't like to have it set to 0. It makes their job more difficult, and it is more expensive of a process to ensure that it's done right. So usually you want to put a little bit of a bend radius in there. That's the radius that, for example, if you zoom up here where the bend is occurring, that's what we're talking about. Okay, so over here, the bend allowance, go with a K factor of 0.34. Notice that there's several different things. There's bend tables, bend allowance, bend deduction, bend calculation. If you want to know more about those, you could always click on the help button up here, the little question mark, and it'll take you to the web. And here you could look up all these different things. So for example, it didn't take me automatically to K factor, but I could type in K, and it'll probably bring me to K factors. And there we go, K factor. And here you can see the equation for a K factor right up there, and then what it all equates to. We're not going to go into those types of details. There are classes that you could further your knowledge of that, but there's also bend calculation tables, and again, there's lots of information here. Depending upon where you're working in the world, as well as the company you work for, they might have different methods. Okay, we're just going to leave the rest at this default. Hit the green check mark. And let's go ahead and save this. So find the little floppy diskette up there, save. And you're going to go ahead and name this P1. And save it maybe to your desktop. Save it someplace you know you're going to be able to find it next time. All right, so we are pretty much, we're looking pretty good there. Let's now see these corners. Those are kind of sharp. That might scratch our phone as we put it in place. So let's put a fillet. Go to the Features tab right up here and find Fillet. Now, set your fillet to, we'll set it to 0.125. Actually, let's set it to 0.2. And it's like filing it down. And so rotate this. The way to rotate, by the way, you could hit your arrow keys on your keyboard and then scroll, or hold that scroll button down, like push it down like it's an actual button, and then move your mouse left, right, up, and down. You'll see it will rotate. Otherwise, use your arrow keys. It will rotate in 15-degree increments and so on. But anyhow, you could rotate. Maybe play with this a little bit before you go putting the fillets on. You might want to pause me for a moment and learn how to rotate a little bit. It's a great thing. Otherwise, you could also hit your space bar, and that brings up some tools too. But anyhow, take a look over here. Let's resume. See that edge right there where my pointer is gliding over? We want to go ahead and click on that, and there you could see the fillet. Now, you may not see that fillet unless you click on Full Preview here. So make sure Full Preview is selected. Now, be very careful. Don't select faces. See, like if I select this face, it just turns blue, because it's too small of a face to add that type of a fillet to. This is an edge. When you see the edge turn orange, make sure you're selecting edges for this one. Click on that and you can see your preview. Let's get the backside too so it doesn't scratch our desk. Go to this corner, click, and this corner and click. Again, I'm using the scroll wheel and I'm pushing it down to rotate. Hit the green check. Okay. Now we're going to go ahead and we're going to flatten this so we can put a design on it. And this is where you're going to want to hand sketch a couple different designs to put on here. So you could pause me for a while and then take out your paper and come up with your hand sketch. But what I'd like to do here is we're going to go ahead and go to the Sheet Metal tab and go to up here, Unfold, and select, let's see, as our fixed face. We could go ahead and select this face as our fixed face and hit Collect All Bends right here on the left and hit the green check mark, and it should flatten it. And there you have your flat pattern. Okay, and this is what we could use to cut it out. We could actually export this and bring it into a drawing, and then export it as a DXF file, which is a very common file format used for laser jet, water jet machines to cut it out. Or you could even just print it out, lay it as a template over your sheet metal, etch it in with a pointer, and then cut it with shears. That might not be, especially 62,000s might be kind of hard there, but usually you want a die press or some other sort of method. But we flattened it in this case so we could actually design our geometry on it. So select this face where I want you to design something and start a sketch. Now hit your space bar, and the space bar brings up this orientation box. See this little button right here? Click on normal 2, or you could use the ice cubes, but in this case we want normal 2, so we go flat or planar to that face. Okay, now I'm going to take and I'm going to draw up here some geometry. I'm going to click and draw out a circle, and then I'm going to click and drag out another circle, and I'm going to make a half moon there, or we could do something else. So let's see, we could make some different lines. So we could go to trim entities, hit escape on your keyboard, go to trim entities up here. You'll see there's extend as well. Oops, didn't want that. Sketch, make sure you're on the sketch tab. The little pair of scissors. And there's power trim or trim to closest. Go ahead and select trim to closest down in the lower left. And then you could select these two geometries, and then it creates something like that. Now I'm going to go ahead and draw a little line through, a little thunderbolt right there and there. Go to trim entities, and you could trim that. You can make it like any sort of Pac-Man with a bump on his head. But anyhow, you get the idea. But just be careful. Don't add, like if you add something in here, like let's say you added an eye. The problem with that is that when this gets cut out, that eye is going to fall out too. So you have to have something in there to hold it. So that's where parallelogram, if you go underneath the line, the rectangle tools, hit the little arrow, you'll find parallelogram. This is a really nice tool. It enables you to click and create a connection between that. And now you could go over here to trim entities and trim out this excess material here. Oops, didn't want that. If you go too far, hit undo and zoom up closer. Click on trim entities again. And here, let's click and remove those. We'll open this up and open that up. Okay, now we could go to features on the left here. Go to extruded cut. This will allow you to cut that geometry out. Over here, since it's sheet metal, you could select link to the thickness of the sheet metal. Check that little box and hit the green check. And so now I have my design. Beware, you could come up with any design you want. I just threw that together. It's really nothing. I was just doodling. Okay, now you go back to sheet metal and find fold, and just hit collect all bends and hit the green check, and it will fold back up, and there's your sheet metal part. Now later on in the next videos, you're going to select a material. What I'd like you to do, go over here to material, actually we'll do it right now. Right click on material on the left and click edit material. This will bring up a materials library of steels, and we're going to learn about steels in this class. So you can select any of those steels. Notice there's aluminum, iron, copper, zinc. Plastic is not a metal, so you can't use that, or any other non-metals or glass. Don't use those, or even carbon fiber is not metal, so stay away from there. But what we're looking at, let's say I wanted to go with an aluminum alloy, and I'm going to go with a very soft 1060 alloy. And you'll see over here you have yield strength, and right now it's an IPS, but we could set it to MPa. Megapascals is what we're going to use in class. That's what MPa stands for. And here we have the yield strength and tensile strength. The yield strength is the point at which if you bend something and it starts to not bend back. Tensile is if you are tearing or pulling this apart, and it basically tears apart. It's the point at which it's actually tearing or necking, what they call. You might hear that. But anyway, the 27.57 is a very low yield strength. That's very soft. An example would be, what can you compare that to? On your body, your bones, typical bones are about 130. So the higher the number, the stronger the material is typically. So 130 megapascals for bone. You might look at some steel. Steel started anywhere at 200, and they go up to, I believe I've seen up to 600 megapascals, even maybe 700 for some alloys, or if it's hardened. And then titanium alloy starts at about 900 and goes up from there. So as you can see, the higher the number, the stronger the material. This at 27 is very soft. Okay, but let's go ahead and hit apply and close, and you'll see it will take upon it the actual visual properties of that. And now you could go to evaluate up here, the tab. And if you go to mass properties, that little scale right there, it will tell you how much it weighs. So mass properties, and right here, it's 0.05 pounds. So depending upon the material you select, it's going to weigh differently. Now, that 1060 alloy, I'd like you to go ahead and Google that, or not, maybe not 1060, pick an alloy, any of those alloys, and Google it and research what you can find on it, and put that down in about a half paragraph, or I should say half sheet paragraph, or maybe 2 paragraphs of what you locate. Again, trying to plagiarize, make sure you are taking the information and using your own words. If you do, make sure you put it in quotes and then you cite your source. And that concludes this exercise. Make sure you save it.